हाय स्टार्ट करूँ अभी क्या?
ईशांत लाइव कर दिया।
We are live.
ओके
करूँ स्टार्ट?
हाँ जी वेट आई विल इंट्रोड्यूस यू देन यू कैन स्टार्ट।
ऑलराइट, ठीक है।
After learning how to make your own website in our previous session with Mr. Piyush, here we are to conduct a session on how to deploy our projects on cloud. Good evening, everybody. I welcome you all to today's session on cloud and DevOps. This session is being organized by HackDefine. HackDefine is a non-profit society that conducts technical and non-technical events across colleges and aims to give life to a coding culture that promotes learning that is motivated by a fascination for new technologies. It gives me immense pleasure to welcome Mr. Pratham Krishna, who specializes in Backend, DevOps, and Cloud. He has been SWE intern at Geo and Ecolite 21 and is certified in AWS. He will be presiding over today's session, and we are looking forward to learn so much from him today. Thank you for joining us today, Pratham. Without further
Thanks
ado,
for this.
I request the speaker to take the session forward. Over to you.
All right, thanks. All right, hi guys. So again, thanks for the introduction. And so I'll just speak about a couple of things that I have worked on and a few things that I'll be covering up today. So yeah, like Akriti introduced, I work on the backend, DevOps, and the cloud. But I also have on the DevOps and I've worked with a lot of tools like CI/CD pipelines, Docker containers, Kubernetes, Terraform, Ansible, and the list goes on. So in today's session, we're going to be covering what DevOps is and why exactly are we using it, and what was the need of having DevOps. Next, we'll be moving on to Docker, why and what is Docker, and I'll show you a simple Docker container deployed on my local system. And after that, I'll speak a little bit about Kubernetes, and post that we'll move to AWS, or initially the cloud, and later on move to AWS. So cool. So let me screen share. Give me a minute. All right. Is my screen visible?
Yes, it is visible.
Cool. So DevOps. So what exactly was the need for DevOps, and where exactly did it actually start? So DevOps started with the idea where there were two teams. There was a development team and the operations team, and they were not ever really in sync. And because of that, the shipping of products or apps actually started to get delayed. So because of this, this concept of DevOps actually came into place, where there's specific engineers who do both development and the operation side of things. So as you can see this diagram over here, so it says planning. So the initial step is planning. Then there's the coding, building, testing, the release, and then the deployment, operations, and monitoring of the applications. So these are like a few day-to-day tasks of the DevOps engineer. Now, coming to the tools that DevOps engineers usually work with, and most of us have actually worked with it. So Git being one of them. So yeah, like Git, uh, one of the most common UIs I use for Git is GitHub or GitLab. But apart from that, if you're a Java developer, you might have worked with Maven. If you actually work with testing and stuff, you would have done Selenium and Junet and stuff. So yeah, there's a lot of tools on the deployment side. There's Docker, there's AWS, there is Azure, there is Google Cloud, there's tons of things. So yeah, these are a few things about what a DevOps engineer works with. Coming to one question that is usually asked, if DevOps engineer is just taking care of the deployment stuff and all and does not really work on the coding side of things. No, the DevOps engineer also works on the coding side of things as well. So coming to the next thing, Docker. So Docker is one of the most common things that actually comes to most of our minds when we say DevOps. So what exactly is Docker, right? So Docker is correlated to the word container. So what it does is it containerizes your applications so that it runs as a specific container. Now, to actually understand this, what we're going to do is this is a file system. Let's say this is your laptop's file system. You're running your application on the bare server. So it is your application is running over here. Now, let's say there's some code which goes wrong, and this leads to the corruption of the entire file system. So what happens is your application goes down, and your entire file system gets broken. And so this entire machine gets screwed up. So you'll have to go with reset, or you'll have to fix these bugs and stuff. So there's a lot of things. So what Docker actually does is, let me just yeah. So what Docker does is it allocates a specific resource on the file system. It could be memory, it could be storage, it could be a lot of other things as well. So what it does is it allocates a specific portion in your file system for this application to run on. So your application runs in this specific portion. So let us say there's something that goes wrong in the code, and this tends to corrupt the file system what it was doing before. So what happens is it corrupts only this containerized section of the file system, and it does not really affect any of this other region. Now, what how exactly does this help? Let us say you have a system or a machine which is running your, let's say, your front end application, your back end application, and your database. Something on the back end goes wrong, and it corrupts the entire file system. So that brings down your front end, your back end, the database, and your entire file system. And that is something we do not want at all. So that is why we containerize our application so that, let us say, the backend goes down, the front end is unaffected, and the database is also unaffected. So that is one reason why we use Docker, and that is what we mean by containerizing application. Now, let us say, okay, so we've actually understood that. Now, why or how do you actually deploy your application to a Docker container? So I'm not really going to go too deep on installing Docker and stuff right now, but I'll actually show you. So this is a UI tool for Docker, which is called Docker Desktop. So you usually install this and Docker onto your system. And okay, so let's actually understand what images is. So every application, so let us say your backend application, is has a specific configuration. For example, it could be running on Node.js version 17 or 14, or it would be running on Java 8 or Java 11. So it has a specific configuration over here. So that specific configuration has to be implemented in this entire container. So that the image that is built by this configuration is called a Docker image. Now, all right, so I'm actually going to show you a Docker file. So a Docker file is usually used to actually build an image and run your image in a container. So if you see this is a simple backend endpoint. So you hit the endpoint slash and you get returned a hello world. So let me just run this application and show you real quick. All right. So also, yeah, Dockerfile is used to set certain configuration properties to your container or the Docker image. Now, it's running on port 8082, right? So yeah, you see hello world is actually being printed. Now, so what we're going to do is, so we have a Docker file over here. So my application is built on Java 8. So I have used OpenJDK 8. So this is the image that has to be used for the container. This is the maintainer. It's up to you if you actually want to specify what a maintainer is. This is the build file that is created. So it is in the target folder over here. So So this is the location of the build file and the name of the file that you want it to be called, or the image should use. And this is the entry point. So if you actually see, let me just open terminal. So let's move into target. And we have the jar file over here, which is Docker demo and the snapshot. So if we actually want to run this jar file normally on our system, we do it Java jar and a Docker demo. So we want this exact same command to be run with this app.jar. So so we've actually set this entry point to be Java, and there is a space, and there's a jar -jar, and there's a space, and then there's app.jar. So this is the configuration that we'll be using for our Docker file. Now, how do we build this file, right? So we're gonna do a Docker build, and we're gonna give it a tag. Let's call it Docker demo. So it's gonna take a little bit of time to actually build. So I actually had a copy already before on my local system, so it didn't take a lot of time. So yeah, coming back, if you actually want to see the images that you have on your local system, you use the command docker images, and you see there's this image called docker demo, and the tag is latest, and your image ID created, and the size of the image. So, so what we're going to do here is we have to run this image. So the command for this is docker run, and we're going to give the image name. So that is docker demo. And before that, let us actually specify the port we're running this on. So it's going to be 8082 and again 8082. So what we're doing here is specifying the container port, that is the second one, and the first one, the port, host port, that is on your system. So we're going to run this. Pew reload. Yeah. So you're running this request, which is actually being sent to the port 8082. That is actually being redirected to your Docker container. So how exactly does it work? So what is happening here is key. Yeah, right. So cool. All right. So let us assume this as your container, and this is your application, right? So your application is running on a specific port. Let's assume this to be at port 8082. Right. Cool. And so let's say we're sending a request. So there's a first request which hits the Docker container. So it'll hit the Docker container on a specific port over here. So let's just call it X. And this container will send a request to your application. And then the whatever the value that is being returned, or whatever your response that is being returned, is returned to the container, the boundaries, let's call it boundaries, and then to your to wherever you're viewing. It could be Postman, it could be another application, it could be the browser like we did right now. So this port X is something you can use any number. You can use 1500, you can use whatever you want, right? So I used 8082 over here. So just because I like that number, right? So yeah, so you can actually use any number over here as long as the port is not being used by some other application, right? So yeah, so that is what Docker really is. Now again, going back to our previous case, that is, what if your application, say your backend application, goes down because of some file system corruption? What happens then? You'll have to manually restart every single thing, right? So you'll have to configure the file system completely and on the file system for that container, and you'll have to check what is actually going wrong in the code. So that is a completely manual process, and that is not what DevOps actually tells you, right? So DevOps promotes automation of things. It tries to bring about 100% uptime, which is of course not 100% uptime. It's not completely possible, but yeah, a very high uptime of your applications. And yeah, so basically what we do in this case is we use something that is called as Kubernetes. So what Kubernetes does is, as the definition goes, let me actually just Google this out for you. Okay. So it is basically for automatic deployment, scaling, management of containerized applications. And as they call it, it is called orchestration of containerized applications. So what exactly happens here is Kubernetes runs what is called as pods. So on a basic architecture diagram, let me see if I can find something. Um, okay, I'll actually just draw it for you. Cool. So Kubernetes has something called as pods, and inside each pod you have a node, and inside each node you have a container running, and inside the container you have the application that is running, right? So pods is the smallest cell or smallest part of what Kubernetes actually does. So what exactly happens is, let us say your containerized application is broken or it has corrupted the file system. So instead of you manually restarting the server, right, or rerunning the container, what actually happens or what Kubernetes actually does is it restarts the pod or the node on itself, all by itself, right? So let us say we have an application and it is running inside a Docker container, and there's a pod over here, and there's another application, there's another container, and there's another pod over here. So what exactly is happening over here is um let us say okay, let us just create a bigger box, which is the file system. So let us say this file system is completely corrupted. So we're just gonna cut this out a bit. And so basically this pod is completely down. So any request that is coming will get redirected to only this. And we always want two pods running at all times. So what Kubernetes actually does is it destroys this complete pod and it creates a new pod. So this new pod has the same container with the same configuration and the same application running. So there's an almost complete uptime for your application. So yeah, so that is what Kubernetes does on a very basic level. Kubernetes also has a lot of other things that it can be done. So one question that every beginner kind of asks is, should we actually run a database in a Docker container or in a Kubernetes pod with a different container, right? You should probably never do that for the only reason that moving into the Kubernetes or the pod context is firstly very tough, and then debugging the entire thing is again very tough in case something goes wrong. Similarly, for a container, a Docker container, it is again tougher to actually move into the container and debug it. So it is never really recommended to run your database inside your Docker container or inside the pod. Now, what is the alternative? You can run it in a separate, you can call it a separate server and have the server backup, say every 1 hour or every 6 hours or something like that, right? So this creates a backup copy, and it is a healthy practice to loosely couple your code. So yeah, that is about Kubernetes. If you actually want to install Kubernetes on Ubuntu or Mac, there's something called as Minikube and kubectl. So you can again refer the Kubernetes documentation, or you could ping me up if you need help with anything. But yeah, so there's something called as Minikube and there's something called as kubectl for both these operating systems. So cool. So we're gonna move to cloud. If there's actually any doubts, if there's someone who asked, is there any doubts? Are we good? Cool. ठीक है. So we're gonna move to the cloud, right? So let us actually start with why cloud, right? So we were using what is called as in-house servers, so they can be in your office or it could be on a separate premise or anything, right? And what exactly was the problem with it is the first question. So the problem with in-house servers is simply that those are maintained by you, and there can be a lot of problems that can actually happen. Firstly, natural calamities. If your main server is gone down, or if you have only one server which is actually been taken care of, and there's a natural calamity which would be a tsunami or it could be anything, and your server goes down, most of your users will not be able to use your applications. So there's a downtime. Now, coming to your server, let's say this is your in-house server. So it has a specific capacity, and say from 12 a.m. to 12 noon. So this 12-hour bracket, there's about 40% usage of the server. For the next 6 hours, so I'm just going to count these numbers: 12 to 12 and 12 to 6, and I'm going to say 6 to 12 again. Okay. So 12 to 12, there's about 40% usage. So let's just call this 40%. 12 to 6, there's about 80% usage of the server. And from 6 to 12, again, it's about 50% usage of the server. So there's that fluctuating usage of the server that is actually happening, but you're paying for this entire server block. So there's that small wastage of money, as it is called, and you really don't want to spend a lot of money on resources that you are not using. So the cloud benefits by you paying only for what you use. Now, let's say in the first case that is of natural calamities and stuff, it is on the cloud provider to actually, if in case there's any downtime of your application, it is the cloud provider's responsibility to actually set up another server, maybe in a different region. But it is its responsibility to actually get things in motion again. It is not on you. So cloud, uh, every cloud has its own specific terms, conditions, policies, and stuff. So we're not going into that, but there's something called as regions and locations where every cloud provider's okay, let me actually uh, servers are actually hosted. So we're going to go through what AWS offers. So there's something called as regions, uh, availability zones, and edge networks. So in terms of regions, there is, okay, let me zoom in a little actually. All right, okay. So there's multiple regions which is actually provided by AWS. In the North America region, there's US East, which is North Virginia. There's Ohio. There is Northern California. There's Oregon. So every region has multiple availability zones. Availability zones are smaller regions where exactly your server is located, right? So US East has 6 availability zones. Ohio has 3. Northern California has 3 of now, and Oregon has 4. The closest region for India right now is Mumbai. So yeah. So there's 3 availability zones in Mumbai. So this is the closest region and the availability zone available for you. Now, so in simple words, regions are a superset of availability zones, and availability zones are, you can say, data centers, right? So that is that. What are edge locations? Edge locations are basically uh, content delivery networks, CDNs as you call it, and they're used for faster delivery of certain static content or cached content to everyone across the globe. So let us say, in a simple example, let us say one of your servers is hosted in, say Ohio, or say, let's call it Northern California actually. So it's somewhere over here. And one of your users is using somewhere in Northern California, and the other user is using in Mumbai. So there's obviously going to be a latency difference. So someone who's in Northern California will get an instant reply of from the server, whereas someone in Mumbai, it might take probably a second more. But yeah, so there's going to be a delay. So what edge networks or edge locations do, or what the content delivery network does exactly is key. It actually sets up certain cached content to certain edge locations. So there's one in Hong Kong, there's one in Shanghai. So what it actually does is if there's any request that is made to the server that is certain, which can be static content or it could be cached, it makes a request to the edge location that is Shanghai, which is the closest. So this is faster response time in simple words. So that is what edge networks really does. Now every cloud has its own different uh, regions and availability zones and edge networks and stuff like that. So we're not going to go too deep into that. You can obviously check out the documentation and stuff. And yeah, so moving on to the next thing, uh, cloud services. We've all heard about S3 buckets, EC2 instances, Lambda functions, and stuff, right? So what exactly are these? So let's actually start with um, S3 buckets. So let me just cool. So S3 buckets are simple storage service. What it does is it stores certain static file for you. So you can actually use a static or any file that is stored in your EC2 instances or your Lambda functions or anywhere else. So it is always recommended to not store dynamic content in your S3 buckets, which would be a server-side hosted application, stuff like that. It is never recommended. You could store your HTML files or jar files, etc., etc. So let us actually open S3 over here. Cool. So okay. So we're gonna create a bucket and we'll just call it a demo bucket. And okay, cool. AWS is the okay, fine. North Virginia. Block all public access. So yeah, cool. So object ownership. So ACLs is basically access control list. So what this does is it allows other AWS. It depends if you actually disable this. Uh, what happens is only you are able to actually use whatever is stored in your S3 bucket. Whereas if you have it enabled, other AWS users can also access the bucket. So coming to the next section, that is block public access settings. So this is again a further in-depth consideration of what you want to actually choose. This bucket versioning, there is tags, the server-side encryption and stuff. So I don't really have any HTML content and stuff left with me. So let me actually just go. So I'm really not gonna be able to show you. Okay, cool. Right. So I'll not be able to show you any HTML content, but this is a simple way of actually creating a bucket. If you want to put in files and stuff, one is obviously the AWS CLI, but you could also upload stuff using the website as well. So for now, I'm actually going to delete this bucket because it's not really of much use right now. But cool. So actually, yeah, cool. So coming to the next AWS service, which is the most heard, is EC2 instances. And so let me just create a box. So EC2 instance, it is Elastic Compute Cloud, and what it actually is infrastructure as a service. So to get a better idea of things, there's something called as platform as a service, which most front-end developers use. That is Heroku, Vercel, and Cloud Foundry, and etc. Netlify again. So those are platform as a service. What is infrastructure as a service? You get a complete control of what is actually happening on a system level. So your local machine is again infrastructure as a service. So you know what is actually happening. You can access the terminal. You have complete control over this system. So that is in simple words what infrastructure as a service means. Now coming to what EC2 actually you know what you'll actually uh, deploy a Java application to the EC2 instance. So I already have the jar file ready over here, and we're going to create a EC2 instance and we're going to deploy it. So so it's publicly accessible. Um, so you click on launch instances once you move to the EC2 section of the AWS console, and let us call it a demo instance one. All right, and we're going to use Amazon Linux, but it's up to you if you want to use Ubuntu, Windows, Red Hat, SUSE Linux, and or Mac or whatever. We're using the free tier one, and instance type is again free tier key pair. So there's a key pair. So let's actually show you. So if you're a first time user, you will have to create a new key pair. So go with the RSA encrypted private and public key pair. If you're using Windows, go with the PPK, and if you're using a Ubuntu or a Mac, I would suggest use PM because it comes with SSH. So let us call it AWS demo, right? So we're going to create a new key pair, and it's going to download that key pair for you. So also keep the key pair safe if you ever want to access the instance ever again, right? So you'll actually see once we get ahead. It's actually okay. Allow SSH traffic from anywhere. Configure storage. So this is again up to you if you want any additional storage. Advanced details is nothing we want to actually put up over here. So we're going to launch this instance. So it's going to take a little bit of time. Cool. I think it's done. All right. So it's going to take a little bit of time to actually start the AWS instance. I'm going to refresh. So there's something called as Iem Rules, which is a security feature for AWS. So it's IAM. It's identity and management. As far as I remember, I don't remember the full thing. But yeah, so what it actually does is, so let us say you have an application and you have a second application. So these are two different services, and your application one has to access a specific AWS resource, for example. So let us actually just call this R, and let us call this A. So this is your application. This is a AWS resource, or you can just call it S3. So to access this S3, you would not want to give your root ID and password to AWS. So what you do instead is you give a IAM role or an IAM user, so that which is a temporary role, and it has very limited access uh, for 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 a limited period. So it's up to you if you actually want to give it for a limited period of time, if you want to give it permanently, but it has a limited access. So let's say you can allow it to only access a specific S3 bucket or all S3 buckets or a specific EC2 instance. You have that flexibility in IAM roles. So this is something you should always set up whenever you create a AWS account. Um, reason one, security. Reason two, if you're actually giving certain access to somebody else to work on an AWS account, always use the IAM, a new IAM role or a user. So let us check this demo instance one. Cool. So let us connect to this. So it's going to take a little bit more time. Cool. So if you're using a Mac or Linux, so this will work perfectly fine for you. So open a terminal. Let me open a new tab, and let us move to the downloads directory. So we have the AWS demo.tem. So what we're going to do is copy this first command. So it allows permissions. The second one is the second last line that you copy over here, SSH, to connect to the instance. So we're going to paste this over here, and we're going to hit enter. So we're going to hit yes. So now you're connected to the AWS EC2 instance. So on a Ubuntu instance, you actually have certain things pre-installed, but on Amazon Linux, you barely have anything installed. So what we're going to do is we're going to install Git and Java. So we're gonna install Git first, and then we're gonna install Java. So yeah, this is what Java is, right? So I'm working with Java 8 over here. So with every different version of Java, you'll have to install using a different command. So it could be OpenJDK 11, or it could be OpenJDK 1.8. So once this is installed, we're going to clone our repository and run it. Cool. So just to actually check the versions, so it's Java 8 and Git, it is 2.32. All right. So we're going to clone this repository over here. And once it is cloned, we can actually move into the directory and we have our jar file. So if you remember, I had shown the command over here that was java jar and whatever your jar file name is. So we're going to do a java jar docker demo. And so yeah, ignore the name, I just gave it by anything. So it is running on port 8082 on the EC2 instance as well. Now, if you actually want it to be accessible from the web, so if you actually open this IP address over here, so yeah, this is a pain. Cool. So there's actually access this at 8082. You will not be able to view whatever your instance or whatever that port is actually returning. So you see it's going to continue loading and there's going to be no return value. So yeah, again, root URI and it should return a hello world. And this is where everyone actually gets stuck. So there's something called as security groups. So I'll show this. Cool. So what security group does is it restricts inbound onto your AWS application. So if you see over here, there's only one security group ID, and it is allowing only SSH say accessibility from any URL or any IP address. I mean, sorry, yeah. So we want it to be accessible from anyone, anywhere. So you click on the type and you select all traffic, and you can go by anywhere. It is not recommended again. So I'll go with my IP address for now, and I'll move it to anywhere after this, and I'll show it to you. So let's go back and our instance over here. So this is IP address. We're going to copy it again. Yeah, so it's again there, and we hit enter, and you can see there's a hello world or a return value from the server. So again, on a reiteration, what security groups actually does is it restricts the access to your EC2 instance. So what it was before was it was only allowing access through SSH from any IP address, and we changed it to uh, all traffic, that is SSH or HTTP, HTTPS or anything, right? And from only our IP address. If we actually change it to anywhere IP4 and save, you will still be able to access it over here. So if anyone actually hits this this IP address with this port number, you will also be able to access this hello world, which is actually being returned over here. So yeah, this is the EC2 instance. This is one problem that most people actually face. Coming to deleting AWS instance. So what we're gonna do over here is so stop the instance first. So stop. Actually, you know what? Terminate it first. Cool. So your instance gets terminated, so it gets stopped and then terminated. So that is about EC2 instances. If you do not really want to work with the infrastructure and you just want a platform to work on, there's something called as AWS. Uh, what is it called? Beanstalk. Right, Elastic Beanstalk. Yeah. So what it does is it is simply used to run web servers and stuff. There's a couple options. Yes. So so we're gonna run a web server environment over here, and not technically run because I am not too keen on Elastic Beanstalk, and it has been kind of down of late. So we could still try actually. So we're gonna call it demo, and we're gonna call it demo environment, whatever. So you don't have to actually fill in, but if you actually want to give an environment name which is custom, you can do that here. If you want a specific domain for yourself, you can do that. Description, you can call it demo for DevOps and Cloud Workshop. Managed platform. So this is again something you should be able to choose. So you have a couple options. That is .NET Core on Linux. So if you're using C Sharp or .NET, there's Docker, there's Glassfish, there's Golang, there is Java, Node.js, PHP, Python, Ruby, and Tomcat. So we're gonna go with Java and sample application or upload your code. Let's go with upload your code, and we're gonna upload our jar file over here, and we're gonna okay. So it'll take some time. So yeah. Also, one more thing you should take care of is your package or the build file should not be really big because it's going to consume as much memory as it can on your EC2 instance. So we're going to create this environment now. One more thing I forgot to mention while we were doing Docker, there's something called as Docker Compose, which follows the YML format of actually writing things. So if you're not too keen on writing a Docker file, what you can do is you can create a docker dash compose dot yml files. It is kind of tricky writing that file, but it's up to you if you want to write a Docker file or a Docker compose. So what we're gonna do here is okay, cool. So this is going to take some time. Until then, let us actually go check out AWS Lambda. So Lambda is basically serverless. What serverless? Okay. So what serverless actually does over here is you don't really need to run a complete server to run things. It could be so basically what a couple things you can actually run on AWS Lambda would be a simple notification service or a simple mail sending service or simple things. You don't want to run a complex backend web hosted application on AWS Lambda. So so you have a couple options here. So you can author from scratch, use a blueprint, container image, browse serverless app repository. So this is something you pick up from the uh, open repository, which is available to everyone on AWS. So you can actually choose a couple things. So there's runtime which you can choose. So there's Java 11, Ruby, Python, Node.js. You have a couple options here. So we're not going to go too deep into Lambda right now. We're going to go back to our Elastic Beanstalk. Cool. So this is definitely going to take some time. Okay, this is taking time. Cool. Okay. So what else do we have over here? RDS, Redshift here. So until then, let us again cover RDS, AWS RDS. So RDS stands for Relational Database Service. So we're gonna open this. You have multiple options to run SQL services, for example, MariaDB, MySQL, Oracle, Postgres. And if you want to run NoSQL, you can use AWS Redshift, and there's a couple other NoSQL services. So let's actually create a database, a demo database. So I'm not going to put it up for long. I'm going to get charged. So you have standard create. There's easy create. So as the description says, you can go with either of them. It's up to you. So there's Amazon Aurora, which is a database provided by AWS. You have MySQL, which is standard MySQL, standard MariaDB, standard Microsoft SQL Server, standard Oracle, and standard PostgreSQL. So we're gonna go with MySQL. Let's pick a older version because that is actually free. Cool. Cool. So you should always create a okay. So yeah, coming back. So we have free tier. So we have a couple options here. That is production, dev test, and free tier. Production may you actually get a very high speed connectivity to the database. Dev or test servers, you get a decent latency, whereas for free tier, you're gonna get the worst of all. So it's up to you, or whatever use case that you have. Um, so we're gonna go with free tier and database instance identifiers. You have to initiate with a database. It's always recommended. Master username, admin, master password. Again, you can go with admin if you want, and admin again. Burstable classes. So cool. We'll go with T3 micro. Um, auto scaling. Let's gonna close that right now. There's connectivity. So this is not really. Just go with the default settings. So you're gonna go with public access. We'll actually turn it on for now. So basically, what it does right over here is key. There's something called as a VPC. So VPC is basically um, it basically stands for virtual private cloud. So what happens inside this is you can have a EC2 instance, you can have a database, you can have another EC2 instance, you can have another EC2 instance, and you can have a database, a backup database over here. So what happens over here is key. If you actually turn on public access, so anyone from outside this VPC, okay, so anyone from outside this VPC can also access your database. Whereas you have this turned off, what happens is only these EC2 instances and this database can access the other database. So that is what public access actually does. Um, moving down, there's password authentication. So let it all on default and estimated monthly cost. So I'm gonna get charged. I'm not gonna create a database right now, but yeah, again, so you have a couple options over here. So once you create a database, you'll actually be assigned an IP address. So you can actually use um, what do you call this? You can use that IP address in your application to actually access the database. So it is very similar to what we did in EC2 instances. So we're gonna go back to um, 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 Elastic Beanstalk. So, okay, yeah. So it's not going to work out because, so yeah, we'll not be able to actually access this endpoint because the health of the instance is actually bad. And this has been the case for a while now. I have reported it to AWS. It's never really worked out well. So we'll not be able to access the endpoint right now. But yeah, you could run your Node.js application, you could run your Java application, you can do a couple things. So basically, this is a platform as a service and not infrastructure as a service. So that is about AWS services. We could actually check out Redshift once. Um, actually, let's not go with Redshift. Let us go with um, DynamoDB. Yeah, this is something you'll actually use instead of say MongoDB and stuff. So DynamoDB is again NoSQL database as it goes. It is fast. So if you actually have to create a table, enter a table name, your partition key. So which is again primary key in terms of SQL. Sort key is what you can call as a foreign key in SQL. Default settings. So this is up to you if you want to go with custom settings or default settings. So yeah, you just need all this information. You can create a table again, accessible from your application through the same IP address, the IP address that is actually provided. Um, cool. So this is actually about AWS. Let me check 1 second. Cool. So I think we have covered most of the things. Regions, edge, locations, right? Right. Pricing about AWS is that okay. So one thing, another point you should know is you get about 1 year of AWS free tier access to most of the services. A couple services, you get about 3 months of access for free. Um, coming to the pricing, let us actually open. Let me just end. Uh, kill this 1 second. Terminate. Okay. Cool. So moving to EC, AWS Cost Calculator. So what we're gonna do over here is we're gonna create an estimate. So you can get a basic idea of the pricing and stuff that you actually have on AWS. So we'll go with an advanced estimate. Operating system, we'll go with Linux. You get to actually decide the kind of workload we will have. So we can go with the constant usage. Number of instances, we stay with one. Uh, Now comes what is called as the types of instances we actually have. So we have the option from the smallest memory sizes to the biggest. It's up to you. So yeah, as you go with the higher memory and higher number of CPUs and network performance, the pricing also increases. So we're gonna go down and let's say we have selected T4G Nano, and so we have a couple plans over here. So this on demand. What on demand actually is key. Let us say we have a EC2 instance. So it's handling about 5,000 requests an hour. Uh, on a specific hour, there's about 6,000 requests that actually come in. So what AWS does is it actually launches another instance with the exact same properties for you. So basically, that is something that is actually happening, and it splits your number of requests to both the EC2 instances. And in cases there's about 3,000 requests per hour only, what AWS does, it shuts down one of these instances and lets you only use one instance. So that is one advantage. So this is actually called as auto scaling, and this comes under the on-demand pricing. Now, as far as all reserved goes for, so you actually reserve a specific amount of instances for a duration that could be 1 or 3 years, and you have options to pay either all at all upfront, or partial upfront, or none upfront. If you pay everything upfront, you pay less. Whereas if you pay nothing and you pay all at the end, you pay a little higher than what you pay upfront, right? So there's that small difference. So again, contract type, there's 1 year and 3 years, like I said. And the spot instances. So you actually get a lot of discount on spot instances. But the problem with spot instances is key. uh, in case there's another application or anyone else who is actually using on demand, your spot instance would actually be shut down for them to use, because they're actually paying for the on demand, and you've bought the spot instance for 90% off. So in this case, it says up to 90% off, but it's relatively cheaper than all others. So there's that small disadvantage. Um, Again, there's something called as an enterprise model for EC2 instances. So basically, certain companies have their reservations against cloud. So basically, uh, they want a complete server of their own. They don't care if they're paying higher and stuff. So AWS also has this option for dedicated servers. So what it does is it puts one entire server block for a specific company if you pay a higher amount, right? So that is about a completely dedicated host. Now that this is about the pricing. Now we're gonna actually scroll down. So you have block storage pricing as well. So snapshots is basically the number of times the EC2 last state was actually looked at. So you don't really need that right now. I mean, in a dev application, you're not going to use a snapshot. So that is not really needed. Storage amount, it's up to you. Again, if you're deploying a database, you should actually note that about 5 MB of storage can store about 50,000 uh, rows of SQL data. Data transfer, you can actually, it's up to you if you have an idea of how much data is actually incoming and outgoing from your EC2 instance. And you're going to get an estimate over here. So in this case, it's about $4, but it really depends on the EC2 instance and the kind of pricing model you actually picked. So I think we have covered everything for this session. If there's actually anything, you could let me know, and yeah, we can see.
Uh, It was great listening from you. There are some doubts that there are in the chat box. I would like to ask them to you.
Cool, cool, cool.
Okay, so is Amazon Aurora a SQL database or no SQL?
Aurora is a SQL database.
Okay, all right. And what is the difference between stop and terminate?
Stop does not completely terminate your EC2 instance. It only stops the instance, which you can actually restart later on. But terminate completely ends your EC2 instance. It stops and destroys whatever the configuration in the EC2 instance that was assigned to you.
All right. Also, is there any limit of container in the Docker?
There's no limit as such. The only limitation that you'll actually face is your system might run out of certain hardware. So that is something you should actually take care of. For example, you cannot run a 4 GB Docker container or a 2 GB RAM system. So that is something.
All right. The next question is it you? It is usually said that to be a DevOps engineer, we usually need to have some sort of certifications. So, how do
Right.
students get one of themselves, and which one?
You don't really need a certification over the cloud. I would definitely suggest you getting a certification because it is looked at a lot of places. So over the cloud, it is always recommend. AWS is more widely used than what Azure and Google Cloud is, but it's up to you. You could get one of the certifications that could be AWS or Azure or Google Cloud. As for DevOps go, I would not really suggest getting a Kubernetes certification or anything of that sort. um, there's one there's a certification done by Red Hat. I'm not sure which one it is, but yeah, you could get that done as well.
Okay, thanks. Okay, the next question is DevOps usually confuses many of us at the first glance because front end and back end are self explanatory. But how I
Right.
explain someone that what DevOps is in simple language, like
Uh,
one who
DevOps in simple language is basically deployment of your applications as well as whatever building you're doing of the code or whatever building of the application is. So it is a mix of building and deploying your application. So, in for a front end engineer, which is more common, uh, folks build a React website and they deploy it to say Vercel or Netlify or anything. So you're actually doing DevOps to some extent. You're using platform as a service, but you're
yeah.
actually doing DevOps to some extent. So
Okay.
yeah,
Also, is there is requirement of prior knowledge like backend and front end if a person has to start with DevOps?
Not really, but I would always suggest a basic idea of things because, for example, if you're writing a Docker file, you would actually have to specify the type of container, what uh, what the image is actually built on. For example, a Java image uses an OpenJDK. A Python uses a PIP or Python, not sure. It uses certain environment configurations. For example, a React app or a JavaScript app would use Node.js environment or NPM. So a very basic idea of programming is always required. That's always nice.
Okay, okay. Also, if a person wants to get started with practicals, what would you recommend to them? Like, students should get started with free tier of AWS or Azure.
I would. It's up to them. I mean, I have used both Azure and AWS, and I've personally liked AWS more, but it's again up to them. You get about 1 year of access free on both these platforms, so it's a win-win either way.
Okay, so one of our wants to know in Geo where you were working as DevOps engineer. If yes, could you share a moment that surprised you in production environment?
I wasn't at Geo I didn't work in Geo as a DevOps engineer. I worked on a full stack project over there, but I worked in Acolyte a bit on a deployment side of things. And I was actually deploying to the test server, so the development server.
Okay.
And what happened was my Java configuration that was used in Dockerfile. didn't really match well with what was actually being used by the application. So there were a lot of runtime failures that actually happened during the entire process. And I think that was one learning. You should always know the uh, version of your application and your project that you're actually using. That is always important.
Okay, okay. So that is it from our side.
Right.
No other questions.
All
Thank you
right.
for joining us today. It was great having you. And I hope everyone gained as much as I have gained from this session. And I hope to interact with you soon, Pratham. Thank you so much.
Sure, sure. Thanks. Thanks.